Okay, today's video is all about bisectors, whether that be segment or angle. Okay, our learning objective is the learner will identify bisectors when given a picture. We'll use properties of bisectors to solve for missing measures and use the angle addition postulate to find the measures of angles. Okay, my colors for the pages are going to be yellow for vocab, orange for math theorems, and my pink pen here for any clarifications I need to do. Okay? So, bisect means to cut into two equal parts. A segment bisector is a point, a ray, a line segment, or plane that intersects the segment to create two congruent parts. So notice it's all of those things. It's not just a point, it's not just a line segment, it could be a point, a ray, a line segment, or plane. Now, last class we talked about a midpoint. The midpoint of a segment is the point that divides the segment into two congruent segments. And then there's lots of things to do here. Okay? So remember, when we're talking about midpoint, the tick marks on either side represent congruent. Okay? So that's something important to be aware of, is the notation for the tick marks. Now then, some clarifications we can answer before we do an example. We have, what do midpoints and segment bisectors have in common, and how are they different? Well, a midpoint and a segment bisector are both points. However, midpoint and segment bisectors are different in the sense that a segment bisector can be a line, a ray, a plane, etc. Okay? Can a segment have more than one midpoint? The answer is no. There can only be one midpoint on a segment. Okay? Each segment only has one middle. Can a segment have more than one bisector? Yes. Okay? Because I could have multiple bisectors at the same midpoint. Okay? So make sure you're aware of that. There can only be one midpoint per segment, but a segment could have multiple bisectors at the same point. So now let's do some examples. We have example 1 here. It says for us we want to find RH, TR, and RA. It says that MR, so MR here is 15, and there's a tick mark here, which means that RH is also 15. So there's the answer to our first one. Then it wants to know what TR is. Okay, well TR, if the whole line here, so from here to here, is 26, then in order to find TR and RA, we know that TR plus RA equals equals TA. We know that TR and RA equal each other, so we could say X plus X equals 26. 2X equals 26, so X equals 13. And so we know that TR and RA, because they're both congruent due to the tick marks, are both going to be 13. Our second example says find the value of X, so that's the goal. I need to solve for X, which means I don't need to plug anything in. It says that TM is 3X plus 5. It says that MQ is X plus 17. Notice we have the two tick marks, which means they are equal, so I can write them equal. I can say TM, segment TM, is congruent to segment MQ. Therefore, TM is equal to MQ, which means that 3X plus 5 is equal to X plus 17. I now do algebra and subtract X on both sides and get 2X plus 5 is equal to 17. I subtract 5 on both sides and get 2X is equal to 12. And then I divide by 2 on both sides and get X equals 6. So that is my final answer. X equals 6. Okay? Moving right along. On this next page, we have example 3. Example 3 says if AM is 5y minus 1, we need to find the value of y, so that's my goal. It says AB, though, so this whole guy, is 38. So this is a part plus part equals whole problem where I know that AM plus MB is equal to AB. And the other thing I know is that AM is equal to MB. So whatever AM is will also be MB. Well, I know AM is 5y minus 1, which means MB is also 5y minus 1, which equals our total of 38. So I end up with 10y minus 2 equals 38, or 10y is equal to 40 when I add 2 to both sides. And if I divide by 10, I get y equals 4. And thus I found the value of y. So sometimes we use part plus part equals whole, but there's a second part to it, which is that the AM is equal to the MB. So notice that I'm using letters before I even attempt to plug anything in. Okay? Our next one is an angle bisector. An angle bisector is a ray that divides the angle into two angles that are congruent. Okay? So a ray that divides an angle into two angles that are congruent or equal. So here we have a picture. Notice the arc marks here, little curves there. Those are the congruent part. So congruent, we'll see arc marks is a clarification for you. Okay? Congruent means comprising of the same shape. So two angles are congruent if they have the same measure. So let's clarify that right there. Congruent is denoted by our little equal sign with a tilde on top. So we see that angle XYW is congruent to angle ZYW. Or you can say the measure, the little m, the measure of angle XYW is equal to the measure of angle ZYW. Okay? But you cannot say that angle XYW is equal to angle ZYW because those are the things, not the values. When we put the little m and an equal sign, we want the value. Similarly, the segment AB is congruent to segment BM, and AM equals BM, but we cannot say that segment AM is equal to segment BM. Next up, we have angle bisector, which is a ray that divides an angle into two congruent angles, or two angles with equal value. Let's write that. Two angles with equal value. Okay? So in this example, I need to find angle PQ, the measure of angle PQR. The measure of angle PQR is equal to, we're not sure right now, so it's equal to x. So I need to solve for x. Okay? We're told that ray QS, so ray QS bisects, so it makes two equal angles, PQR. And we know that PQS is 24 degrees. Well, since angle PQS is congruent to angle RQS because of the reason of angle bisector, the definition of an angle bisector, then I know that the measure of angle PQS is equal to the measure of angle RQS, and therefore okay. So we need to find the measure PQR. I misread that earlier, so PQR is going to be not x, but the angle PQS, the measure of angle PQS plus the measure of angle RQS. So if I know that PQS is 24, then I know that that also equals RQS, which means that they're both 24. So if I come in and plug these in, I know that 24 plus 24 will equal PQR, so my answer is 48 degrees. So the measure of angle PQR is equal to 48 degrees. And that is how we do that. On our last page of notes here, we have a proof. So if you notice in the proof, once again, the picture and all information for the picture is the given. Then we have angle PQR is congruent to angle SRQ by the definition of an angle bisector. Since it told us that ray RQ is a bisector, then we know that both angles on either side are congruent. That is these angles. So then we can say that their values are equal because that's the definition of congruent. Now we plug in the value, which is substitution, then we algebra it out. So let's take a look at example 2 here. Example 2, our goal is to find x and the measure of angle AFC. So AFC I'm going to highlight in orange so I know where it is. We have this guy. Okay? And it tells me that AFB is angle AFB is 3x plus 4. So this guy is 3x plus 4. I know that it told me that FB bisects, so I know that this guy and this guy are congruent. So I can say if BFC is 34 and I need AFC, then I can say that 3x plus 4 is equal to 34 because the measure of angle AFC equals the measure of angle BFC because of the definition of angle bisector. Which means that I then subtract 4 from both sides. I get 3x equals 30. And I get x equals 10 when I divide both sides by 3. So there's my x. Now I need to plug that in. Well, I know that the measure of AFC is going to be the same as the measure of angle BFC. So I know that this is also 34 degrees. Our last example here is if the measure of angle CFE equals 10y plus 32 and the measure of angle DFE equals 7y, find y and CFD. Okay, so I need to find y and the measure of angle CFD. So we can use yellow here. So we have the angle CFD that we're looking for. We're told that CFE, angle CFE, is 10y plus 32. I notice that that is a hole. We know that ray FD bisects, so I know that these two angles are congruent. And I know that angle DFE is equal to 7y. Which means that this is a part plus part equals whole because I have a whole angle, but my parts are the same. So part plus part equals whole. I know that angle CFD is equal to or congruent to angle EFD. So I can say that DFE or EFD is 7y plus 7y is equal to 10y plus 32. I then combine like terms and get 14y is equal to 10y plus 32. I subtract 10y from both sides to get 4y is equal to 32. If I continue it, I get 4y divided by 4 is equal to 32 divided by 4, and therefore y equals 8. So I found my y. Now I need to find my angle CFD. Well, angle CFD is equal to 7y, so the measure of angle CFD is equal to 7y, which means that it's equal to 7 times 8, which means that it's equal to 56 degrees. And that is how you use bisectors and the angle addition postulate in order to solve for x in various angles.